we are discussing modern capital budgeting techniques, namely the net present value, benefit cost ratio, and internal rate of return. These three are most widely used investment evaluation techniques in the industry. These techniques are also called as discounted cash flow techniques because they consider the time value of money and they use the discounting as the process. Hence, they are called as discounted cash flow techniques. Let us consider an investment project where the life of the project is 4 years. At the end of the year 0, you have a cash outflow of 40,000, followed by 4 years cash inflows, as you see it on the screen. So, given the required rate of return as 10%, will you be accepting the project? So, if you were to decide, we can actually divide this cash flow stream into two components. What you see as cash inflows are actually the benefits from the project, and what you see as the cash outflow is actually the cost of the project. Now, you are all aware that we compare the costs and benefits, popularly known as benefit cost analysis. But as students who know the time value of money, we are not going to compare the total benefits with the total cost. Rather, we have to compare the present value of benefits with present value of cost. That's where we respect the time value of money, and hence these are called discounted cash flow techniques. So we don't compare costs and benefits, whereas the benefits are spread at different time periods. So you will have to take all the benefits to a neutral point. So that's where if you are calculating the present value of these benefits, then you are bringing the worth of all these benefits which are spread over 4 years to their 0-year equivalent. And of course, there are 3 different ways of comparing the present value of cost with the present value of benefits. So the first way is that we'll be comparing them to know the difference between present value of benefits and present value of cost, which will actually result in the net present value. Now, the present value of benefits can be calculated like this. That means you take the cash flow in every year, then divide it with 1 plus k. Here k is 10% to the power of the year it is happening. That means for the first year, cash flows have to be discounted for 1 year. The cash flows that are happening in the second year will be discounted for 2 years. The cash flows that are happening in the third year will be discounted for 3 years, and so on. And you add all these discounted cash flows, then you get the present value of benefits. Whereas the present value of cost is same because it is already in the 0 year. So you need not do anything to find out the present value of cost. It will be simply equal to 40,000. And once you have the present value of benefits and present value of cost, you can take a difference between the benefits and cost. That is called as net present value. So net here means difference. So if you take the difference between the benefits and cost, the present value of benefits and present value of cost, that is called net present value. And needless to say, when the present value of benefits are more than the present value of cost, we will be accepting the project, which also means when the present value of benefits are more than the present value of cost, the NPV will be more than 0. So if you look at the accept reject criterion for the NPV, you accept a project if its NPV is greater than 0. That means the present value of benefits are more than the present value of cost. And you reject a project if the NPV is less than 0. That means the present value of cost will be more than present value of benefits. And you may be indifferent if it is equal to 0, where the present value of benefits and the present value of costs are same. When you have 2 projects, of the 2 projects, the one with a higher NPV is preferable. So when you're actually choosing between 2 projects, then you should see for which project the NPV is more, and that project has to be chosen. So now let us calculate the NPV for the present problem at hand. So, you know this timeline. So we have the 11,300 happening at the uh, end of year 1, 12,769 happening at the end of the year 2, right? 14,429, 16,305. And for each of these cash flows, you will have to find out the present value. That means you have to discount them. So we discount them individually. So let us say for the cash flow that's happening at the end of the year 1, it is 11,300 divided by 1 plus 0.10 whole to the power of 1. So which is 11,300 divided by 1.1000. So now what will be the value of this? So I'll just use a calculator. So now you see 11,300 divided by 1.1 is 10,272. I'll take it as 10,273. So this is 10,273. Then you have 12,769 divided by 1.2100. It is 10,552.89. So let us take it as 10,553. 10,553. Now we have
10,040.7.
12,769 divided by 1.21. It's 10,553. 12,769. Then 14,429 divided by 1.3310. So this is 10,841. 10,841. Now we have 16,305.
11,536.5.
Yeah, 16,305. Just divided by 1.4641. 16,305 divided by 1.4641 is 11,137. So 11,137. So add all of them. Ten 273 plus 10,553 plus 10,841 plus 11,137. So it is 42,804. 42,804. So now your NPV will be the present value of benefits, that is 42,804 minus the present value of cost. The present value of cost is 40,000. So NPV is 2,804. If the NPV is positive, NPV is greater than 0, so you accept this project. So, but then if you have seen, this calculation is a kind of a concern because it is involving a lot of. So of course I have made it simple by pre-calculating this 1.01 whole to the power of 1, 2, 3, 4 values for you. Otherwise you will have to do it again. So as an alternative calculation, we can actually calculate NPV using what is called as the finance tables or present value interest factor tables. So the present value interest factor tables will be given at the end of each textbook. and or you can make your own copy of the tables in an Excel sheet. So the present value or future value tables are the tables which are actually pre-calculated values for different combinations of percentages and different combinations of the years. You remember this formula, the present value present value formula. Present value is equal to the future value divided by 1 plus k whole to the power of n. So 1 by 1 plus k whole to the power of n, these values for different percentages and for different years are called present value interest factor values. So now what we normally do, we just take the amount aside and we only keep the the interest factor into account. So for example, let us say this is our future values. Now for these future values I'll have to find out the present values. So now we know that our percentage is 10%. Now let us look into the table. So here you go to the table, you go to the 10% values. Now for the first year the value is 0.9091. That means it is the value of 1 divided by 1 plus 0.1 whole to the power of 1. So directly you can multiply your values with this. Means 0.9091, 0.9091, and then you have 0.8264, 0.8264. Then for the third year, 0.7513, 0.7513. Then for the fourth year, it is 0.6830. 0.6830. Now, if you multiply the net cash flow with the present value interest factor, then you get the present value directly. So now let us see 11,300 multiplied by 0.9091. So you get 10,272.83. Let me take it as 10,273. 10,273. You can now check. This is same as what we got here, 10,273. Now, what is there in the table? 1 by 1 plus k whole to the power of n. Remember, what you have in the table is 1 by 1 plus k whole to the power of n. So you should be multiplying your cash flow with the table value, not dividing your cash flow with the table value. If you want to divide the cash flow with your table value, then you have another table called future value interest factor table. You see, these are the values. These are directly 1 plus k whole to the power of n values. If you take these values, then what you are doing, you are dividing. You see here 1.1, 1.21, 1.3310, 1.4641 are the values here. 1.1 is 1 plus 0.10 to the power of 1. 1 plus 0.10 to the power of 2 is 1.21. So these are the four values that you see in future value interest factor tables. But these values are present value interest factor. Present value interest factor is nothing but 1 by 1 plus k whole to the power of n. So you have to be careful in choosing which value you are using. But I suggest to use the present value interest factor tables because you most of the time you are engaged in finding out the present value, and you can directly multiply the given value with the present value interest factor. So we can show this as another demonstration. Second value, let us see, 12,769 multiplied by 0.8264 is equal to 10,552. So 10,000. 10,552. So remember, this is same as the value got here. Of course, we got here 3. That's a rounding off. So it doesn't matter, right? So we'll take this as 553. Then 10,841. You need not check it now, it will be same. 11,137. So 11,137. Now you take the total as 42,804. 42,804. Then from this, you less present value of cost. Yeah, 42,804. Less your present value of cost 40,000. So you will be getting the net present value, that is 2,804. So what we do, we'll be using increasingly the present value interest factor tables, right? So that it makes our job more easier. So this is how we can calculate NPV, and based on the value of NPV, you know how to interpret it. So based on the value of NPV, so if it is more than 0, you accept the project. Less than 0, you reject the project. If it is equal to 0, you are indifferent. But when you have two projects, the one with a higher NPV is preferable. Yeah, any questions?